have to say that when I was planning for this talk, it was a bit hard for me to figure out the level of the conversation because we want to make sure that we keep it at a high level without going into too much of the details, and FHE is indeed a complex topic. So what I'm going to do is I'm going to cover actually why do we even need FHE to begin with. Second is we're going to talk a bit about what FHE is. And third is when FHE meets AI. So I want to start maybe with the basic assumption that I hope most of the people here understand, that there is something that's common to all blockchains out there, and it is that the first thing that they need to do is to verify whether a transaction is valid. And the second thing is that they need to verify whether a contract was executed correctly. What it actually means is that in order to do so, they need to reach into consensus over public data. And if we think about it, what it actually means is that what blockchains offer is correctness, but they don't offer any type of confidentiality or privacy, and that all on-chain data is public.
Stop the side conversation.
So now the question comes about privacy, and I have to say I have a mixed opinion about the word privacy because I think that people don't really understand what privacy means or have some kind of thoughts on that. So when we talk about privacy, we typically talk about two things. The first thing is anonymity, and that is the ability to hide the identity of the person who does the transaction. There's been several projects that have solved that. Some of them didn't end well for the founders. And then the second part is actually confidentiality, which means the ability to provide private inputs. So if we think about Bitcoin, it's the ability to hide the amount that's being sent. But if the more interesting use case when we're talking about Ethereum, it's actually the right to have the network itself working on arbitrary data. So how do we solve it? How do we introduce confidentiality into the blockchain? And the solution is confidential smart contracts. So there's been a lot of research invested in confidential smart contracts. The assumption today is in order to solve that, you need to use some sort of a privacy enhancing technology. We like to use the term PATS for that. But I also have to say that there isn't a silver bullet, at least not until now, that was able to solve all the problems that are out there, which is why we started Fhenix. But we definitely see that this is becoming widespread in practice. So there are actually quite a lot of projects trying to solve that. So how do we actually deal with confidential smart contracts? We have the user, in our case Alice. Alice is able to send an encrypted input. The input is then computed or executed on the chain itself. We have the state that's being updated, and we have an output that's being sent back to Alice. So let's look at an example of how that actually works. And since we're in a how FHE meets AI topic, I decided to take the use case of sealed bid auctions. But let's think about decentralized AI training data set. So if we're thinking about the future, where we're going to have a lot of data on chain, or at least the hope that will be used to support better AI algorithms, and they're going to be marketplace for that. We want to make sure that we have a good auction mechanism, and sealed bid auction is really the right solution. So how does the sealed bid auction mechanism actually works? Let's say that Alice wants to buy a new data set to train her model. She's able to make a bid for that, let's say 5 ETH in that respect, but that bid is actually sent encrypted. She sends her bid for 5 ETH. The private input is actually updated, but nobody else can see the amount that she bidded, which is a bit different than what we have today when the data is public. Now we have Bob. Bob sends his bid. He's unable to see what Alice bid, so in our case, he will bid 10. The state gets updated again with another private input. We'll have a few more that makes the bidding, and when the bidding ends, there is actually an execution that happens, and the result can be seen as a public result for everybody, and we know that it's trusted. So there's been several solutions trying to solve that problem, whether that's EKP or TEEs or MPCs. Briefly going to talk about some of the limitations that they force. So ZK, I think 2024, everybody understands ZK. It's a proving mechanism. It works great for scalability, but it offers single user privacy. It's really not the end game for data confidentiality. The other technology, multi-party computation, enables to split the computation into multiple entities, but also there, we like to mention that MPC is great, but MPC is communication bound. It doesn't scale well when you have multiple entities. which is why you're actually seeing NPCs in cases of wallet, where you have a user and a custodian. But if you try to extend it, it just wouldn't work. And then we have TEEs, Trusted Execution Environment, that enables you to run the computation in hardware. The problem with TEEs, or say, before I talk about the problems, I love TEEs. I used to do TEEs in my past, and I think TEEs are great. The challenge with TEEs is that, A, they are prone to side channel attacks. I think some of you may have heard of recent attacks that happened. And the crypto ecosystem doesn't like to trust hardware. They like to trust math. So hence, fully homomorphic encryption, I like to say, the new kid on the block. Fully homomorphic encryption enables you to run computation over encrypted data. I'll say it again, you can do computation over encrypted data, which sounds a bit kind of magic, but it actually works. And the reason that it works is when you encrypt the data, you maintain the mathematical structure of the data that you encrypt, and then you can actually compute over that encrypted data and get the result back. So FHE has been out there for several years, always associated with two problems. One, it was considered as slow, and the second part, it was considered as very complex to implement. So if we think about the complexity of it, I would say today, it's mostly slow. Like, we're super friendly to the developers. I think Inko also mentioned it maybe before. EVM compatible, developers can really build like very, very quick. So I'd say complexity is mostly solved. On the performance side, there's been progression on two fronts. First of all, better FHE schemes that has been developed, and I think we're going to have Zama here as well, giving a talk. And the second part is that there are actually, I would say, over a dozen companies that are building hardware acceleration for FHE. You can see a partial list here, there are actually a few more. So from our standpoint, FHE is still complex, but it's getting better and faster, and every time it's computation bound, the problem is actually getting solved. So we at Fhenix believe that the right way to bring FHE into the ecosystem is through a rollup. For those of you who don't know what a rollup is, it's basically a mechanism that enables better scalability. And in our case, we enable users to send their encrypted input into the rollup. The rollup in the sequencer, in that case sequence, organizes the transaction, executes the transaction, and then we have the settlement, the security that's done on the L1, plus a decryption network that enables you to decrypt the code if needed, as well as verification that can be done through fraud proofs in our case. The second way to bring FHE into the market is actually through coprocessors. So if you think about the world today, we have tons of L1s, tons of L2s, tons of L3s, and you want to make sure that they're able to utilize FHE. A coprocessor is really the right way to do that. What a coprocessor is an off-chain computation mechanism. So the L1 or L2 or L3 can actually call a smart contract, send the computation with a smart contract. The coprocessor would capture that, would execute, would send the response back. It's a very easy way to integrate FHE without actually building on top of the L1, the L2 that we provide. So with that, I'll take a few minutes just to talk about AI and crypto, and then when FHE meets crypto. So there's been a lot of discussions happening around AI and crypto and how they interconnect. My mental model of how AI meets crypto is actually that if you think about AI, it brings creativity, it brings intelligence, but it's actually non-deterministic. Like you run a model, you get different results every time. When you think about blockchains, what blockchain offers is actually a deterministic platform that offers trust. And it's quite useful when you're looking into payments and markets. And that fit actually works really, really well. And it generates a lot of interesting applications. Specifically, when we start to think about when AI meets blockchain with FHE, I'll talk for a couple of examples. The first one is decentralized AI. So when we want to scale AI, we need to make sure that we get better data feeds for training models. We want to make sure that users are able to bring their data. Blockchain does a phenomenal job in incentivizing them, but if users are now providing private data, they need to make sure that their data is protected, where FHE really shines. The second part is if you think about the future. Today, most of the AI that we talk is, we can call it corporate AI. It's managed by a couple of large entities, but we definitely start to see a trend of having decentralized AI models. And if you want to have these models deployed in a decentralized way, if we maintain the current shape of just going with all data public, it will be very, very hard to maintain privacy and IP of these decentralized models, which is, again, where FHE is going to solve it. Private queries is another great example. You want to make sure that when you send a query, that it's not transferable, that it's not obviously seen to everybody. So private query, say, is a hot topic to be addressed. Sealed bid auctions, we talked about that. And then I also want to share a bit about like the vision of agent-to-agent transaction. So take a bit of a mental model and think about where we're going to see the internet heading in the next couple of years. So today we see tons of AI agents being popped up. When you want to sign up to all of the conferences here today, you need to go, you need to fill a lot of forms, this is my company, this is where I am. But it's actually quite easy to have an AI agent that would do that for us. On the other side, now the entity that receives the information can also be an AI agent. And I would say we're probably going to see these agent-to-agent conversations that are happening, which you can actually look at them as transactions, which where crypto really brings significant value. And then lastly, and I'll finish with that, I want to talk about trusted AI and two problems that AI introduced that we can solve with crypto and FHE. The first one is proof of authenticity of data. When you see data today, you don't really know the origin of the data. Just a couple of days ago, Google released this phenomenal tool that enables you to generate podcast of like 8 minutes of people doing conversations. You would never believe that this is done through an AI agent. The ability to have the trust of blockchain for proof of authenticity of data is super, super important, and we're going to see a lot more of that. And then lastly, proof of humanity, as we start seeing more and more AI bots and AI agents out there, the ability to prove that the origin is actually a human being is going to scale significantly.